In the continuation of the discussion about forces, we're done with the frictional force, contact force. What about this non-contact force called the gravitational force? So this time, we're going to analyze the mechanism of gravity and how it affects the motion of the object. Would you be surprised if you see a kind of light magic like this or see yourself levitating? You'd be surprised? I think there's something, right? There's a force present, but you can't see it. Therefore, gravity is the force by which a planet or other body throws objects toward its center. That's the location of the gravity. It is at the center of our Earth or even other heavenly bodies. Another thing that I want you to learn about is you are using this gravity to make the object fall, right? And let's see, one person who thought about this is, of course, the famous Isaac Newton. In here, he concluded that the force acts to pull objects straight down toward the center of the earth. Like this. Look at that. Even you draw the ball, it will not go to the outer space because it was been pulled by the gravity. And remember when I told you something about falling objects, when there is no friction or air resistance force, whether that's heavy or light, both of them will reach the ground at the same time. Again, it's the gravity that pulled them down. In the Universal Gravitational Force, Newton realized that gravity acts everywhere in the universe, not just here on Earth. It's everywhere in our universe. It is the kind of force that makes an apple fall on the ground. Remember the story about the discovery of this gravitational force. It is also the force that keeps the moon orbiting around the Earth, or making this Earth orbiting around the sun. It is the force that keeps all the planets in our solar system orbiting around the sun, like what I told you before. What Newton realized now called the law of universal gravitation. The law of universal gravitation states that the force of gravity acts between all objects in the universe. This means that any two objects in the universe, without exemption, they attract each other. You are attracted not only to Earth, but also to all the other objects around you. However, you do not notice the attraction among objects because these forces are small compared to the force of Earth's attraction. So what are the factors affecting the gravity? Two factors that may affect the gravitational attraction between objects, and these are the mass and the distance. In mass is a measure of the amount of matter in an object, and the SI unit for mass is kilogram. 1 kilogram is the mass of about 400 modern pennies. So everything that has mass is made up of matter. That's the definition of matter. The more mass an object has, the greater its gravitational force. Let's say the heavier you are, the greater the pull of gravity on you. Because of the sun's mass is so great, it exerts a large gravitational force on the planets. The reason why it can hold all of these 8 planets revolving around it. That's one reason why. Another thing that affects the gravity is the distance, not only the mass, but also the distance. In addition to mass, gravitational force depends on the distance between the objects, meaning the farther apart two objects are, the lesser the gravitational force between them. For a spacecraft traveling towards Mars, Earth's gravitational pull decreases because it's getting far from the Earth as the spacecraft's distance from the Earth increases. Eventually, the gravitational pull of Mars becomes greater than Earth's, and the spacecraft is more attracted toward Mars. Is it a mass or weight? What's the difference between the two? Mass is sometimes confused with weight, right? Mass is a measure of the amount of matter in an object. Weight is a measure of the gravitational force exerted on the object. Eventually, it depends on the gravity of the planet. The force of gravity on a person or object at the surface of a planet is known as weight. So when you step on a bathroom scale, you are determining the gravitational force of Earth exerting on you. Look at the difference. I have 2 kilograms. That's the mass of the object. Same objects. Same scale. And I'm going to place it on Earth, Moon, deep space. Look the difference between. Weight varies with the strength of the gravitational force, but mass does not. Always remember that. For you to be able to measure the weight of the object, there should be gravity on it. Suppose you weigh yourself on Earth to be 100 newtons, then you travel to Mars, you weigh yourself again, then you might be surprised that your weight is now 38 newtons, not 100. Your weight less on Mars because the Mars mass is only a fraction of the Earth, and as well as gravity. What about gravity and motion? On Earth, gravity is a downward force that affects all objects, like free fall. That's the first example. When the only force acting on the object is gravity, the object is said to be in free fall. An object in free fall is accelerating downward. In free fall, the force of gravity is an unbalanced force, making the object move, which causes an object to accelerate downward. So how much do objects accelerate as they fall? Near the surface of the Earth, the acceleration due to gravity is 9.8 meter per second squared. Remember, that's the gravity of the Earth. This means that for every second an object is falling, its velocity increases by 9.8 meter per second. Look at the time in seconds, and look what happened, the difference between the velocity of a falling object. Starting at 0, then after a while, turns out to be 50 meter per second. While it may seem hard to believe at first, all objects in free fall accelerate at the same rate regardless of their masses. The 2 falling objects in the figure will demonstrate this principle. You see that? If you're going to compare them. In line with this, remember when there's no air resistance force, both objects will move. Whether it's heavy or light, they are going to reach the ground at the same time. If you are going to remove the air, because the air is the force that opposes gravitational force. So remember that motion or friction acts on direction opposite to motion. So air resistance is an upward force exerted on falling objects. Air resistance is not the same for all objects. Always remember that. Falling objects with a greater surface area experience more air resistance. Like let's say paper. It has a greater surface surface area than feather, so it will have more air resistance force acting on it. But in a vacuum, where there is no air, all objects fall with exactly at the same rate of acceleration. The third example is a projectile motion. Well, a projectile that is thrown horizontally land on the ground at the same time as an object that is dropped. Let's see. Rather than dropping a ball straight down, what happens if you throw it horizontally? So again, we call it projectile, like this. The yellow ball was given a horizontal push at the same time as the red ball was dropped. Free fall versus, there you go. Even though the yellow ball moves horizontally, the force of gravity continues to act on it. In the same way, it acts on the red ball. Surprise, right? The yellow ball falls at the same time with the red ball. Thus, both balls will hit the ground exactly at the same time. Again, we call that projectile motion. And these are the applications of projectile motion. There you go, we're done with the gravitational force, and I hope you learned something from this review. Thank you very much again for watching.